Okay, for today we are doing a little bit of review for our big chapter test on exponentials, Unit 11. And the one on tomorrow is using the calculator, so I figured we should spend a little bit of time together doing the calculator stuff today. So I had kids write this equation for $2 gas going up at some unknown rate to $3 gas, and then what we try to do is solve for the rate. There is two ways. One way is to graph both sides and see where they cross. So y equals 3. And I'm going to put a y equals 3 here. And then the other side would be y equals, clear this off, 2 times parentheses, 1 plus the rate, which is we're going to call x because we don't know what it is, to the power of, little caret thingy, 3. And then when I graph that, I'm going to graph both of those equations, graph both sides, and I see where they cross. And if I can see where they cross like that, I just have to go second, calculate, intersect. And one more thing on this. If there are two places, which in a minute there will be, if there's two places, you can't just hit intersect and have it find both. You got to get close to where they actually cross and then go enter, enter, enter. There's a more complicated way than that where you're trying to select each line. But to me, if you only graph 2 lines at a time, just hit enter, enter, enter. It's really fast. And the answer is 0.144. That means 14.47% increase in gas prices. All right, so let's do another one like this and see if you can hang with the notation. That's what's going to be harder on this next one. If I said third root of x squared is equal to 5, and you had to graph that, how on earth are you supposed to do third root on a calculator? I'll give you a hint. Make it into, yes, there is something on the math button that would work, but there's a way easier way. X to the power of what? This is the same as x to the power of what? 2/3. Very good. If you know how to set that up, you got another set of problems right for your test, because that's the power, that's the root. That's the root, that's the power. All I did is rewrite the problem. Now, in this case, if I want to solve this thing, do you get, I can put both of them to the power of, flip it, what would it be? 3/2. And if I do that, I can just take 5 to the 3/2 power and get my answer. But, wait, there's more. Why is there actually, saw another catch here. What's the catch? There's 2 answers because we did a root on both sides. Now, the cool part here is when I ask you to graph this, see, a lot of kids would have just done, oh, power of 3/2. I know you would. You would have grabbed your calculator, said 5 to the power of, you did use the caret thingy, and then you flip this 3/2. That would be wrong in so many levels. Number one thing, you need a parenthesis around there. Number 2 thing, the calculator will only give you one answer. Guess what happens when I graph both sides and see where they cross? There'll be 2 answers. Everybody, please graph this thing, graph both sides of this thing, and see where they cross. You'll see, yeah, you might have to move your graph window out so that you can see further out. You'll see why I always say that we use an absolute value of x. I'll pause for a second. Let me try that. Okay, so here I've got my 2 equations, x to the 2/3 and 5. But when I graph them, I may not be able to see it because it might go off my window. All depends on what your window is. If you can't see where the 2 lines cross, you better zoom out or go to your window and make x and y get bigger. I can almost see where they cross, but I can't quite. So I better go further left and right, which is the x numbers. So I'm going to go to my window. My x numbers, I'm going to go from negative like 20 to positive 20. That'll make me go further out left and right. do you get why I keep saying that we need an absolute value? All right. The only reason mine looks like it's got a little bit of a curve to it is because my what I have on my x and y axis are so different. On my y-axis, I'm going to 20 in both directions. On my x-axis, I'm only going to 10. Or, sorry, the other way around. My x-axis, I'm going to 20 in both directions. So a total of 40 this way. And this way, I've only got a total of 20. So that's why it makes it look a little curved. But all right. How do I find where they cross? There's two answers. Why? Because it should have an absolute value of the x. And I go second, calculate, intersect. But you can't just slap it down and go enter, 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 because you don't know which answer you're going to jump to. You should go, okay, first I'm going to find this answer over here. So you get closer to it. Honestly, you don't have to get much closer. You just have to be closer to this one than the other one. And I go enter, enter, enter. And boom, it jumps to that spot where they crossed. And did you get 11.18? Raise your hand if you did. Okay, good. Then the other one, second, calculate, intersect. And this one's important because if you don't move closer to the other intersection, you're just going to get the same answer again. And then I got to go over closer to this one. So I got to keep moving until I'm closer to the left one than I am to the right one. And now I've gone past the halfway mark, so I should jump to the left side. And there we go. Negative 11.18. So I got two answers. Positive 11.18, negative 11.18. Okay, so do you get the graph both sides and see where they cross would have made you aware there were two answers? As opposed to the other way, you might have just thought, oh, 5 to the power of 3/2, which would have only given you that answer. So it's a good way. All right, but let me show you the alternative. Let me show you why you might want to consider not graphing both sides and seeing where they cross on every single problem. Let's say I had this one. 2, actually 12 equals 6, 1 plus the r to the, let's say, second power. All right. I want you to, actually, let's make this a game. We'll see who's fastest. Graph both sides and see where they cross. Or, now wait, can't start yet. Clear your calculator's screen so that the people with the y equals screen have it cleared so that you have a fair shot at actually typing in, you know, because if you have to go clean your y equals screen off, it'll make you slower, right? So go to your y equals screen, everybody, because you don't know which one you're going to do. You're going to know if you're going to be graphing both sides, see where they cross, or if you're going to be doing it the other way. The other way is faster. All right. You know what? To make it really fair, as I know some people right now are already typing in the y equals and stuff, and that'll skew our answers. I'm going to show you how the two ways are, and then I'm going to give you another problem just like this, and see if you can beat graph both sides and see where they cross, because I think you can. It's this other way is faster. Who knows the other way? Yes. Solve it like an equation. So then what? Divide by 6, divide by 6. You see how fast this is? What's 12 divided by 6? 2. So that's just a 2. Do I need a calculator for that? No. And then what's the next step? Square root. Now I will have to do square root of 2. And when I did square root, is that going to bring in an absolute value? Yes, it is. Okay. So I have absolute value of 1 plus r equals square root of 2. Now I have to rewrite it as two equations. 1 plus r equals square root of 2, and 1 plus r equals negative square root of 2. And then I subtract 1 from both sides. And I've got my answers already, and I can't even help it. It's square root of 2 minus 1 and negative square root of 2 minus 1. Those are my two answers. That's pretty fast. All right, I'm going to give you another one where I believe you'll be able to do it with your calculator, but not graphing. So in other words, that same process we were just doing, except whenever you get stuck on a hard one, you can use the calculator to do the math for it. So, ready? This side of the room, I want this side of the room to do the graph both sides and see where they cross. This side of the room, I'm actually going to walk you through, because it's not fair. We've done so much graph both sides and see where they cross, but I'm going to walk you guys through what steps. You have to use your calculator, but you can't graph. You have to do it this other way, but you can use calculator whenever you're stuck. All right, so here is the problem on your mark. We're going to see who's done first. And if you're done on this side, I'm going to watch for hands. As soon as you're done, raise your hand. Okay? All right. You can't be done yet. All right. So, ready? 8 equals 12. 1 plus r to the third. You guys are graphing both sides. We're seeing where they cross. So you guys over here, you start by dividing by 12. You can use your calculator for that part if you want to. Then you put it to the power of 1/3. Oh, we already got an answer. And then you subtract 1. All right. So far, graph both sides and see where they cross is winning. Got 3 people who have graphed both sides already. It's 4. Now it's starting to get closer to tied. We got 3 to 5. Graph both sides is winning. But part of that is that the graph both sides people are used to that. We've practiced that a lot. Okay, good. Thank you. Now, I want you to switch places and see. But first of all, what did you get when you graphed both sides? Graph both sides, see where they cross. The answer was r equals what? Or x equals what? Negative what? All right. Okay. And did you get that also? Yeah. All right. And I want to note that the person who got it first did not graph both sides and see where they crossed. They used the other way. All right. So the other way, because now you guys are going to switch. You guys have graphed both sides. Now you got to do it the other way. You guys got to do it the way you're used to. Graph both sides, see where they cross. Here's what you guys would have done if you weren't graphing both sides. You would have divided by 12. And you can go, oh, so it's 8 divided by 12. Calculator can do that part, right? You get a decimal. And then you put it to the power of what? 1/3. Remember when you put it to a power of 1/3, put it in parentheses, because half the calculators out there will do it wrong. If you do have a fraction and you don't put it in parentheses. It's just a really good idea for the ACT too. Anytime you're putting in a fraction in your calculator, put it in parentheses. Because it stops this from happening. 2 to the power of 3 divided by 4. The calculator thinks, oh, I'll put 2 to the third first. And then I'll divide the answer by 4. That's totally different than 2 to the power of 3/4. You want to force this to stay together. That's why you need parentheses. Okay, so here's the new problem. And this time, the left side, from my perspective, the left side of the room, the guys that were graphing both sides, you can't. You got to do it the other way. You guys will graph both sides and see where they cross. Ready? On your mark. Get set. Go. Oh, wait a minute. Let me erase her on the wrong thing. Sorry. 10 equals 15. 1 plus r to the 5th. Can't do it by graphing left side of the room. Right side of the room, you're using graphing for the first time. Okay. The not graph both sides got first answer. But now the graph both sides have cut up in my head. Now it's kind of close to a tie. Pretty much a tie. Still. All right, good enough. Stop. Thank you. So that time it was a tie. All I'm trying to make the point is, do you get that there's another alternative to graph both sides, see where they cross? All right. But I think graph both sides, see where they cross is really good. But if you're having trouble with it, go the other way, which would have been divide by 15. And then 10/15. I just reduced that right away to 2/3 in my head. But if you can't, you take a calculator and you go 10 divided by 15, and it would give you 0.666. Okay. Then you put it to the power of what? 1/5, or to the power of 0.2 is even smarter, because 1/5 is 0.2. Okay. That'll be a little faster. And then when this is gone, what's left? Subtract 1. Because the r isn't alone yet, we have to subtract 1 from both sides. And that would have gotten you your final answer. And what did you get for a final answer? Yes? 0.077. Negative 0.077. And did anybody on this side of the room verify that number? Okay, a lot of people got the same thing. Okay, good. So, moral of the story, you can graph both sides and see where it crosses. Or you can just solve it like a regular equation, and I like to call this get the clump alone. And this right here is the clump. And then to finish off that part, you have to put it to the 1/5 power after the clump is alone. Okay, any other questions about that kind? All right, then here's the hardest kind of all. This was like $15 pizzas right now become $10 pizzas over time. Can that happen? It's rare, but yes, it's called deflation. When prices go down, and it actually really messes with the economy, because if you know prices are going down, let's say that you were about to buy something that was kind of expensive. Do you get if prices are going down, you're going to say, I'm just going to wait because it's going to get cheaper. And then if everybody stops buying things because they're like, I'm just going to wait, then its cycle starts to get worse and worse. Like nobody's buying stuff. We got to lower prices even more to get people to buy stuff. And then, you see what I mean? It's kind of a weird opposite cycle. You've never seen it in your lifetime. There's never been deflation in your lifetime. There hasn't been deflation in my lifetime either, as an economy as a whole. Individual items, sure, individual items go down in price, but as a country, we've never seen deflation in a long time. Okay, but deflation is one of the worst things that can happen. And right now, the government's really trying to keep us from having deflation by making lots of cheap money, as in they lowered interest rates really low. You've seen that because if you have a bank account, you get pretty much 0 interest. Back a number of years ago, you could have got like 8 or 10% interest in your bank account. It was as high as 13% interest in the bank accounts at one point. But they've pressed interest rates down really low, especially lately. In fact, it's gone to 0. And there's some countries that are talking about paying negative interest, which means, yes. And so we're going to say a day maybe in this country where you put $1,000 in the bank, and at the end of the year, you can have $995 back. Negative interest. Exactly. Why would you put it in the bank? So people would say, I should just spend this money. And that's what they're trying to get you to do. Because they want people to spend more money because it'll stimulate the economy. So they're trying to drive people to say, I'm not going to put it in the bank. I'll actually lose it. I'm going to go buy a car. And then that's going to cause the economy to get better because that's the theory anyway. So negative interest rates, it's actually possible. Here's another weird thing then. So when the bank lends you money, they pay you to take it. You know how you normally pay interest, right? There are countries right now that will pay you to take money from them, and then you get to pay it back, but you don't have to pay back as much as they gave you. It's all topsy-turvy, negative interest. It's like weird. I know you're thinking like, yeah, I want one of those deals. Sign me up. Okay? But then that makes you have a whole bunch of money, and then what does that make you want to do with it? Spend it, and that makes the economy get better. And so anyway, but you still have to pay them back. So yeah, but the amount of money that you get back is proportional to how long you kept it. So if you only kept it for like a month, you're going to get like $10 out of the deal. Not too smart. Okay. All right. So anyway, I think I'm trying to show you how the economy works at the same time as this math. Anyway, this was starting with a bigger amount and it got smaller. And this was how many years. But what if this had been a mix of compounded monthly? There's only one little change. Divide by 12 right here, but that brings up a really important point. Times by 12 over here, because if I say 5 years, but this is in months, it gets all messed up. So to fix it, I times by 12 there, and my 5 years becomes 5 times 12 is 60 months. Then the problem is balanced, and this is in months and that's in months. What you don't want to do is have one part in years and the other part in months. That would be bad, and you'll get it wrong. Yes?
What if the top part, what if the top exponent was a fraction?
What if that was a fraction? All right. So that would be less than a year. Could you imagine a scenario where it was less than a year, like a half a year? That could happen. That's okay. But then if we do it monthly and I have a half a year, do you get I still have to times by 12 here? Whatever you do here, you do here. Because then half of a year times 12 would give you 6 months. It fixes it. It turns this into months. If you start with years and you times it by the 12, you'll get months. And that way this is in months and that's in months. So let me give you a scenario like that, see if you're smart enough to catch it. Ready? You're starting with $1,000, you're going to put it in the bank. They're going to give you 4% interest compounded daily. And even though I know we just finished a leap year, use 365, not 365.25 technically, if you want to be really smart. All right, so anyway, then 4 years later, how much money you got? Now see if you made the calculation right. We started with $1,000. So did you say y equals 1,000 times, what did you say?
1 plus 0.04 divided by compounded 365.
I agree, divided by 365. Keep going.
And then parentheses, and then put it to the 4 times 365.
Why don't you just say 4? I said 4 years.
Daily.
Because you got to make it days. Because we made this days, so we made this days by times and by 365. And there would be your right equation to put in. 4% interest. 4% interest compounded daily. Okay. That was a tough one because you changed from days to... All right, one more like that. I had $500. I gave it to Larry down the street who was going to invest it in oil futures. Okay? And Larry turned my $500 into $800. And he said I was getting 4%, but compounded quarterly. How long did I have to leave it with Larry? I'll say that again. I had $500. By the end, I had $800. He was getting me 4% compounded quarterly. How long did I have to leave it with Larry to get that? All right, I don't even need you to do the whole graph both sides, see where they cross. You could if you want to, but the main thing was, could you set it up right? I like to think of these as start value first. Then the end value goes over here. Then this is 1 plus the rate, but in this case, I know the rate. It's 0.04 over 4, right, because it was quarterly. Then I put it to the power of, and now this is important, if you just put x, do you get what's going to be wrong? Your answer would be in quarters, which would be really weird. And you'd want the answer in years, so you times it by 4, and now your answer's back in years. Do you get what I'm saying? If you had left it as an x, that's okay, but you got to know what you got there. If you didn't times by 4, what you would have is quarters. If you do the same thing as here, then your answer is what you would expect. It's years. And if you actually graph both sides and see where they cross, it takes a long time. How long did it take? How many years? Somebody actually do it? Anybody graph? What'd you get? 11.8 years. Some of you guys are only like 15 years old. That means you gave it to him when you were 2.5 years old. So $500 turns into $800. You'll be like, wow, that's not exactly awesome. But it's because there's only 4% growth. And generally, people like to get better than that if they can. That's why a lot of people invest in the stock market. What? Maybe, how did you give it to Larry? That's what I want to know. He maybe came to your house and took it out of your dresser or something. All right, so anyway, maybe it was your gifts, your birth gifts. I don't know if that's even a thing. Housewarming gifts? Yeah. Was it really? Really? So when a baby was born, people brought him stuff? Huh. Oh, nice, happy thoughts. Okay, so I wanted to go over a lot of stuff from the calculator today because that's what's on the test tomorrow. But the assignment I'm giving you, I would recommend, since it's not actually due tomorrow, even though the test is tomorrow, that you pick and choose out of it and get the stuff done tonight that's got the calculator stuff. Know what I mean? Because the calculator part's tomorrow. Then the next night, you can work on the non-calculator part and keep that fresh in your mind so you're ready for that part of the test. Okay? And that's all I've got for you for today.